With power functions, we're looking at the form f of x equals a times x to the n, where a and n are both non-zero constants, and n is an exponent. So we're going to make some generalizations of power functions by examining the graphs for different values of the exponent n. And we're going to pay close attention to the n behavior, meaning same or opposite, and we'll explain that when we get to it. And then the effect the exponent has when you substitute in numbers for x. So if n is positive and even, we're going to make a generalization. So let's go to our graph. We'll go to y equals, and we're going to put x squared in y1 and x to the fourth in y2. So that'll be n, the exponent, is a positive and even number. Now what I'm going to do is in x2, I'm going to use my arrow key to scroll over to the icon next to the y2. And if I press enter a few times, once will make it be thicker when it graphs it. That'll shade above, shade below. This one here will graph it kind of as like a little bouncy ball you can follow. So you can see the difference in the two graphs. Okay, I'm going to zoom 6 to get the standard window. So zoom 6. The first one is y equals x squared, which is our basic parabola. And then there is x to the fourth. So we can see the x to the fourth is steeper than y equals x squared. If I press trace, right now I'm on y1 equals x squared, so I'm on the first graph, and I just press 2 and then enter, it'll take me to that point on the graph, so the point 0.24. If I use the arrow key to scroll up to the other graph, okay, so now I'm on y2. Okay, so if I press trace and then scroll up, now I'm on y2, and then if I press 2 and then enter, it takes me to 16, which is above the graph that it's showing. It's kind of out of the range, but it's showing me that the point 216 is on the graph. So we can see that y equals x to the fourth increases at a much faster rate than y equals x squared does. I'm going to zoom in on the origin to show you what happens there. So zoom in. And I could choose the point I want to zoom in on. Okay, I'm going to scroll down. And then over to 0, 0, or very close to 0, 0. Press enter, and that zooms in. There's x squared, and then there's x to the fourth. And you can see what happens with x to the fourth, it gets more flat near the point 0, 0. So where it hits the axis, kind of at the bottom or the minimum of the graph, the higher exponent will be a flatter curve on the bottom. And that happens between -1 and 1. That's because you're looking at fractions. So for example, 1/2 squared is 1/4. 1/2 to the fourth is 1/16, which is a smaller answer. So that's why the larger the exponent, the flatter it'll get. Okay, let me show you by graphing y3 is x to the 6. And we'll see that come in here. You saw it come in there. That's actually a little bit flatter even when it approaches the x-axis. If I do zoom 6 again, we have x squared, and then x to the fourth, and then here comes x to the 6. Whatever, it graphed it, but yeah, there it is. It graphed it. It's steeper. It just looks like it's very close because of the steepness of it. Okay, but that'll be even steeper than x squared and x to the fourth, and flatter on the bottom. Okay, so just in general, we're not going to go through every single example like this. That was just to give you an idea. But this is what I want you to do, is kind of look at the behavior and kind of summarize the behavior. So this was just kind of a general sketch of the graphs. You only have to do one of them if you want. So x squared or x to the fourth, you get the same general idea. It'll have the same end behavior. And what that's saying is, if you look at the left and right end, the arrows are going in the same direction. So that's the same end behavior. They have the basic U shape, and it flattens out near the vertex as n gets larger. So the larger the exponent is, the more flat the bottom here becomes near the vertex. Okay, so if you do the same thing, or the same idea, if n is positive and odd. Oh, and before we get there, I did want to mention one more thing. So to look at the effect the exponent has when you substitute in numbers for x, so the reason we have the same n behavior here, if you put a number like a number way out to the right, like positive 100, when you do 100 squared or 100 to the fourth, you get a very large positive answer. If you do negative 100 squared, well, negative times negative is a positive, so you get a very large positive answer. So that's why you have the same n behavior here. If you did x to the fourth and you put negative 100 in for x, again, you're multiplying a negative number an even amount of times, which will make your answer positive. So you have the same n behavior. And I'll also just point out here that if you had a being a negative number, so suppose you did negative x squared, that just reflects it in the x-axis, and it would still have the same n behavior. They'd just both be going down, or in that direction downward, rather than going in the same direction this way. So if you do the same idea, just graph a few where n is positive and odd, and then if n is negative and even, so positive and odd would be like x to the first, x to the third, x to the fifth, and so on. So I suggest you pause the video and try that, and I'll show you what I have for the solutions. Okay, so there is, if n is positive and odd, we get opposite n behavior, we get that basic little squiggly shape, and then it flattens out near 0, 0 as n gets larger. Same idea as the other curve flattening out near the vertex. This flattens out near 0, 0. So right here. Okay, and then if n is negative and even, and then if n is negative and odd, here's the solutions here. Okay, and these, you'll notice what happens is you end up with asymptotes. And the reasoning is, when you have a negative exponent, remember that flips the base. So x to the negative 1 is really 1 over x. X to the negative 3 is really 1 over x cubed. If you do x to the negative 2, that's 1 over x squared. So then what happens is that negative exponent introduces division, and remember we cannot divide by 0. So that'll introduce asymptotes into our graph. Okay, so make sure you get those answers down. VA meaning vertical asymptote, and HA meaning horizontal asymptote. And then we have the basic shape. Okay, so I'm graphing 1 over x. And notice on the calculator, this is where you have to be smarter than the calculator. It looks like it starts right here and then maybe starts up here and down here. But remember that your calculator just can't draw that. As you put larger and larger numbers in for x. So for example, if you put 100 in for x, 100 squared is a very large number. 1 divided by that number is close to 0. It's not exactly 0, but it's close to 0. So when you go way out here to the right, your graph is approaching 0 but not reaching it. Put a negative number in, like negative 100, and you'll see what happens is you get another positive answer. So that's why on this graph we're still above the axis. Okay, this is the graph that I have up there. That's 1 over x, so when x is negative and odd. Okay, so just make sure that you understand in the calculator that when it has asymptotes, sometimes you have to really pay attention to the graph, that it's not just starting or stopping there. Okay, and then the last page, looking at a few more power functions. We have x to the 1/2 and x to the 1/4. And notice there that these bring in roots or radicals. So a 1/2 exponent is a square root. A 1/4 exponent is a fourth root. So those are only defined when x is 0 or positive, because you can't take a square root of a negative number and get a real answer. And then when you have x to the 1/3, x to the 1/5, those are cube roots and fifth roots. And you can get negative answers there, or you can put negative numbers in for x, because you have an odd number of multiples. Okay, and then this is the last couple, x to the 2/3 and x to the 3/2. And what you might notice is, as long as that exponent is less than 1, notice we have a curve that, whether it's two pieces of the curve like this, or just the one in the part of the curve that's in the first quadrant, you have a curve like that. When your exponent's larger than 1, you have a curve upward. So rather than the curve downward, we have a curve upward. That's because y equals x to the first is a straight line, y equals x. So if the exponent is larger than 1, it's going to curve upward. If it's less than 1, it's going to curve downward like this.